Alright, so for this next video we are going to walk through the procedures of doing RSA and HRV analyses from our segmented ECG data. So from our home screen in Acqknowledge 5.0, I'm going to click on a graph file from disk. And I'm going to open up so we're getting these files from the Dropbox, AceLab, Studies, Dear Study, Dear OA, SJ Practice Data, and then our practice for OA here. And I'm just going to pull up one of these videos. Now, some of these videos might have some information on them that I'm going to show you how to actually extract, but we're going to clear those off first and foremost. So I'm going to just open up the Kaleidoscope video. Okay, so we've actually done some of the analyses on this video prior, or on this data set prior to this video, but we're going to walk through and do that again. Okay, so I'm going to first and foremost go to our arrow tool here, and I'm going to click on one of these events and clear on edit event, and I'm going to clear all of them off. And I'm going to say yes. Okay, so all our events are no longer present. Okay, now I'm going to get rid of this second channel right here, which is one that shows up when you do the RSA analyses through Acqknowledge, but you don't have to worry about that right now. Okay. So the first thing we need to do is we need to detect all of our R peaks, and our R peaks are going to be within this ECG signal that you see in channel 13. All of these little spikes refer to the heartbeats. Okay, the heartbeats, which are defined by QRS complex, R being the peak of that complex. All right, and in terms of heart rate variability, we're interested in the kind of the change in terms of the distance between these peaks, so the interbeat interval. That should and specifically in the context of RSA, whereby these beats vary as a function of respiration. So heart rate speeds up when you inhale and slows down when you exhale, and then also this variability will change as a function of emotional arousal, cognitive effort, etc. Okay, so the first thing we want to make sure and do is make sure that our channel 13 is highlighted. You can also highlight channel 1 by just left-clicking on the left bar here. But we want to do this first because we want the Acqknowledge to denote each of these peaks. So we go to Analysis, we go to Locate Human ECG Complex Boundaries. Okay. So we'll see that each of these waveforms, each of these R peaks, should have a QRS labeled at the top. And that is how Acqknowledge denotes an R peak. Okay? So what we're going to do is add in a couple of these because you notice that this wave that does look like an identifiable R peak is not being selected. And we scroll through to see if there's any others that are missing that also need to be selected. And it would appear that right here, this one is not selected. All right, so what we want to do is we want to move to our I-beam tool, which is over here on the left, and we want to, actually before we do that, let's deselect the respiration channel 1 so that we're only working with the ECG channel. So go to the magnifying glass tool before you check the I-beam tool and zoom in to the waveform here. Okay, so this allows us to get a little bit more precision in terms of where we label this QRS peak. So go back to the I-beam tool and you want to position it right at the middle of this peak of this waveform, or somewhere near the middle. Approximate it as close as you can. Okay. Once you've done that, go to the very top and then right click where it says Insert New Event. Okay, now with this event right here, you're going to highlight it so that it's now in red. And then go over here. Now this is open because I had popped it up in order to get rid of all of these labelings. But if this wasn't here, what you would do is you would right click and then click on Edit Event. And then this window will pop up. So what we want to do is we want to change the type of the signal here, or what type of event that we want labeled. We go down to hemodynamic, we go over to ECG complex boundaries, and we choose QRS peak. Okay, so now you see a QRS that looks just like this QRS. Now we want this to actually be on the wave itself, not off the graph. So what we have to do is we go to channel, and we scroll down three spots here to the channel 13. Because if you look over here, all these channels go in order. So 1, 2, 13. Channel 13 is ECG. That's where we want it. We select channel 13. Okay. So use this bar up here as a guide to know which of these channels you should be selecting onto. So if channel 13 was the second one listed, you would select the second option on your channel. Okay? So now that we have the QRS labeled here, we're going to do the same thing at the very beginning because that peak was also not labeled for the first one that was shown. So move our I-beam over to the center of the peak, go to the top and right click, insert new event, left click that event so it turns red, go to hemodynamic, ECG complex, QRS peak, and then change it to channel 13. Okay, so now that we have all of our peaks detected, we're going to go ahead and zoom out. So just go back and pick your magnifying glass, right click somewhere on the graph, and just go to zoom back. Okay, and then we're going to bring up our respiration channel again. So alt click left for 1. Okay, now what we're going to do is we're going to calculate a RSA value for this entire file. Okay, so we're going to now go to Analysis, HRV and RSA, and RSA time series. Okay. Now for the ECG leads to source channel that comes up on this window, we want it to be channel 13 because ECG is denoted by channel 13. So scroll down to channel 13. Respiration source you can leave because that's already in channel 1, and that's how we have it. We want to generate logarithmic RSA because that's the actual DV that we use for our RSA analyses, and then we want it for the entire graph. Okay, and then you can go ahead and click OK. Okay, so now what you're going to see here is an entire Excel spreadsheet for the RSA data. Okay, and all of these that you see here are going to be the cycles, which are basically around 3 to 6 seconds to 4, somewhere around that range in terms of the IBIs within that particular range. Okay, and the most reliable RSA data can typically be garnered if you have at least 30 cycles of an ECG signal. Okay, and since we have way more than that, we're up to 44. RSA is a much more reliable estimate. Okay, the one thing that I'm going to do here is I'm actually just going to average out the total RSA across these 44 cycles just by going equals, average, and then just highlighting this entire column. Okay, so that denotes our average RSA value from Acqknowledge. Okay, so now in the next video what I'm going to show you, or just an extension of this video, is to show you how we would gather this data, this same value right here, this logarithmic RSA value, in another program. Now we're going to do the RSA analyses through Kubios. Now, if you have good respiration data in Acqknowledge, typically we would want to use Acqknowledge as our main means for analyzing RSA because that's going to be tied to the actual participant's respiration range. However, with bad RSA or wide variability bad respiration or wide variability in respiration, the one thing that Kubios does is allows us to get an estimate of RSA that doesn't necessarily need to account for individual differences in breathing rate. It uses the same frequency band in terms of the typical human adult respiration range of about 9 to 22 breaths per minute to extrapolate RSA. So we're going to go ahead and just open up the kaleidoscope video in Kubios. Okay, now this is the reason why we save our Acqknowledge files as Windows Acqknowledge 3 files so that we can use it in this program. Okay, so since this file was already used previously when we were doing some analyses, it actually opened right up to it. But again, you're just going to go through Dropbox, go through the file path in order to get to wherever your stimuli happen to be. So go ahead and click on Class Scope. Okay, and then there appears to be a potential snafu here. So let's just try another video here. Okay, I think I know what might be happening here. Alright, so let me actually just find another version. I think the problem with these here is that we've added new information to these acknowledge files when we ran through different versions of acknowledge here. So I'm just going to pull up a older one. Okay. It really doesn't matter what file it is. But. Okay, so what you're going to see here is we want to make sure that the R peaks are being detected by Kubios just like they are in acknowledge, but here in Kubios they have just a little red cross is the denotion of a R peak. So we'll just scroll through, make sure there are no artifacts, and all peaks are detected, and they in fact are. Okay, a couple things we're going to do. First, we want to eliminate any drift components to the signal, so we go down to the remove trend components, select first order, which is any linear drift, linear trend. Okay, and then from there we're going to get our RSA value from the frequency domain. Okay. The frequency domain gives us RSA from the high frequency band, which runs from 0.15 to 0.4 hertz, which is breaths, basically per second, or number of samples per second here. And so this is the actual value, the non-log transformed RSA, under the power millisecond squared under the HF column. So we come to the power millisecond squared row, HF column, and that's the value that you want. Okay. Now, this is a different file from what we were working with, or a different participant than we were working with that we got the data from acknowledge, but let's assume that it's the same person. What we would do here is we would then transform this value into a logarithmic RSA from Kubios. Okay, and then for that you just click on equals ln parentheses and then type in 2056.6. Okay, and so that's our RSA value that we would have from Kubios. Okay, so notice obviously this is a different RSA value than we have it's coming from a completely different participant, so yeah, it's not surprising that these two are very different from each other, but you might even see a lot of variability between these two values because, again, this one right here is going to be an estimate of RSA based on, what would we assume is a typical respiration range. This one is more specific to that individual's true respiration range, so there might be a little bit difference here. Okay, so I actually saved this file before restarting the video, but basically you're just going to save this file to be the name of the video and the participant number, and then save this in the participants folder so that you can go back and access these values and input them into whatever analysis program that we will have. Okay, so the next videos that we're going to show are going to detail how we actually work through cleaning a signal in acknowledge.